In the age of AI, data doesn't just sit still. It pulls everything toward it. Cost, compute, carbon, trust. This is the force reshaping the enterprise. You can spend millions on accelerators, but without the right data layer, you'll never see the return. Hello, everyone. I'm your host, Wallace Mills, and this is Modern Enterprise Unpacked. In this episode, we turn our attention to a pressure point few leaders see clearly: data gravity, the pull that determines performance, cost, carbon impact, resilience, and the very credibility of automated decisions. To explore it, I'm joined by someone who has spent his career at the center of the world's most demanding data environments, Ken Claffey, CEO of VDURA. His work spans more than 25 years across Seagate, Xeratech, Adaptec, and Eurologic, helping build the storage systems behind nearly 40% of the world's top supercomputers and leading enterprise storage through the rise of cloud and hyperscale computing. Today at VDURA, he's shaping a new chapter, one where storage is no longer a commodity, but a capability layer for AI acceleration and trust. Ken, welcome. It's a pleasure to have you here.
Thank you
Good
for
to have
having me. Excited.
Yeah, so glad to have you here. We are deep in our series on AI readiness bottlenecks, and today we're focusing on one that's often invisible until it slows everything down, and that's storage. You simply can't run AI without it, and yet it's still treated like an afterthought across most enterprises.
Turns out data is pretty important to AI. Yeah, who knew?
Yeah, yeah. And it's funny because I feel like everybody started with that, and then I feel like we really kind of got away from the roots. So we're gonna go back
Okay.
to where it all began. And one of the first things I wanted to ask you about was storage is often the silent constraint behind AI performance. From your perspective, why is the data layer still the most overlooked yet decisive factor in enterprise AI momentum today?
Yeah, it's a great question. I see the same thing when I talk with customers, and I think the best explanation I can give is very simply it's economics. And it's humans. But when you're building a house, building any infrastructure, you generally fitting out your kitchen, you're going to look at what's the most expensive thing I'm going to buy, and everything else flows after that. AI infrastructure is very similar, right? If you're building AI infrastructure, more than 60% of your budget is going to go on compute and GPUs. And understandably, then, when there's so much money involved in these big capital acquisitions, that's where the focus goes. Because that's where the majority of the money is that you're going to go and get capital approval for, etc. So I think that's really why storage is, in many cases, a secondary afterthought. Compute, 60% or more of the budget. Storage, roughly about 10%. So I
Mm,
think it's the economics that drives people's attention. But to your point, that's 60% of your budget that you're putting on GPUs is going to be wasted if you don't have the right data storage infrastructure behind it.
that's remarkable, especially considering that the entire AI stack collapses without it. As models grow and architectures distribute, how do storage, location, data tiering, and system design directly influence speed, cost, and even the carbon footprint of AI workloads? You use that
Yeah.
house as a example.
Yeah, so I think honestly, the key points that you made there was distributed architecture. So we're really going through this huge architectural shift, and I think Jensen has kind of coined it well, where he talked about if you will, the fall of general purpose computing
Mhm.
and the rise of accelerated computing. And it is that fundamental architectural shift to accelerated computing that means, yes, the compute is more distributed than it's ever been before. Very much going back to my HPC roots, we're used to distributed computing. You're used to having, compute clusters of many nodes, thousands of nodes, tens of thousands of nodes. And ergo, the backend storage infrastructure also needs to have that core distributed capability. Very much, obviously, so much talk in AI infrastructure for storage is around the need for parallel file systems, which at a very simple essence enables you to take a bunch of disparate storage nodes, bring them together, concatenate together into one very scalable from a capacity and specifically from a linear performance perspective, scalable data storage infrastructure. So yeah, if you're for a customer, you're thinking about obviously you're going to have X many numbers of GPU nodes and X many number of x86 nodes today, you got to think about, I'm going to continue to add, that compute cluster is going to continue to grow. I need a backend data storage infrastructure that has the same fundamental distributed storage capabilities. Those distributed storage capabilities needs to be parallel. So again, I can scale in lockstep my storage cluster infrastructure to meet the needs of the growing, GPU cluster.
And does that architectural approach also help enterprises break out of siloed data patterns?
Yes, I think that, it was a good related question right there, in that when people think of AI and infrastructure, people use the term AI pipeline, and I think it's an appropriate term. I think unfortunately I'm seeing is that people are making this, again, it's like fashion. So we just keep on repeating the same mistakes of the past. So people start thinking about their AI storage infrastructure in silos. What do I need for pre-training? What do I need for training? What do I need for fine-tuning? What do I need for inference? You got to always be careful of complexity, and silos brings complexity. And of course,
Mhm.
we want the whole idea of the more data that we have together that's accessible through a common protocol, a common language. You want to make sure that's in one coherent storage infrastructure that meets the needs of your AI pipeline at every stage.
Mm, excellent. That's awesome. Yes, because that's one of the biggest hurdles I've seen across enterprises is that siloed data issue. As there's where the data lives, there's a silo issue, there's, the level or the degree to which it's taken into consideration. But I think one of the biggest things that I'm realizing as people start to figure out what their AI alignment story is going to look like for themselves and for their companies is trust. Trust has become one of the biggest hurdles, especially as enterprises are questioning about how, where, and with what data their models are trained. How can storage evolve from a backend utility into an active trust engine for the business?
Yeah, I probably would caution people to start with the foundation. So what I mean by that is, again, if you're building, you have running an AI factory and we're on the factory floor, what is data is the foundation of that factory, if you will. Before we start thinking about lineage, auditability, and integrity, and I see this all the time. There's some, frankly, sexy marketing from some company, and they get people thinking about these application and management capabilities, but you got to get the foundation right. So the foundation here when it comes to data storage infrastructure is the infrastructure available? And by the way, and that is again, when I go searching for those files, is the storage infrastructure up and running? Can I get access to those files? The next thing is when I go and get access to those files, is the data actually there? So is the infrastructure available? Yes. Or is it down? If it's available, is the data that I'm looking for there, i.e., durable? Is it durable? And is it the data correct? Is it not corrupted? So these like are fundamentals. It's like confidentiality, integrity, availability, CIA of data, if you will. Same thing for storage. So what I've seen customers starting to do is really do a better job of specifying not just performance, API interfaces, management, etc. It's getting the fundamentals right. What availability do I want to specify? What durability do I want to specify? Again, in many cases, one of the things when you think about the cloud initially, certainly the public cloud, people were concerned about trust. And in some respects, there's still some of those concerns today. But fundamentally, that was addressed by having an SLA in place. And part of that SLA is not just about performance and price per terabyte and price per gigabytes per second. It's specifying, in measured number of nines, the availability required, the durability required. So that's a big focus for us, and we want to make sure that as in terms of the foundation of the architecture and the infrastructure we provide our customers, not only are we meeting your performance requirements and then some, making sure we also meet more holistic SLA and get in terms of API integration management, absolutely auditability. But the other pieces that are just so fundamental is, again, those things don't matter if your system is not available, if your data is not
Mhm.
accessible, and if your data is not corrupted. So, yeah, I would say to people, and I continue to say to people, Yeah, everyone that has historically done a really good job of specifying the speeds and feeds, not so much specifying the other parts of the SLA that's just so crucial. And if you don't get that right, it's very easy in a storage infrastructure to flip a bit. And does that translate in when I'm running my LLM that it gives me the wrong answer?
Mm,
Possibly. Indeed, probably. So we've got to make sure that the infrastructure, the foundation of which this AI factory is running, is solid.
I love that. That's such an important reminder. Without a reliable foundation, everything else becomes noise.
Yeah, the other
Where the
things are
issues
like
are.
again like management attributes and add-ons. But if the foundation is not right, you're building your house in quicksand. Let's make sure
Mm.
the factory's got a solid foundation, and then that enables all the tools, reports that we want to run to give you the right answer. So I see people going for the shiny toy,
Mm.
giving the management infrastructure, but then just not specifying that, hey, Mr. Architect, I want to have a solid foundation. As we were talking about earlier in California, if you can't handle the earthquakes, which is basically in storage systems terms, is when devices fail or where storage nodes fail or where networks go down. If you can't handle that, doesn't matter how pretty your house is.
Yeah, this is true. You just can't operate. If you're listening and realizing that storage rarely shows up in your AI discussions, you're not alone. Most enterprises still treat it as a procurement decision instead of a performance, risk, and credibility decision. But as AI workloads expand, the data layer determines everything from speed and energy consumption to regulatory exposure and competitive velocity. This is why we're unpacking it, because leaders cannot afford to make AI decisions without understanding the infrastructure that makes intelligence possible. These are the kinds of topics and challenges we help enterprises and leaders address at Modern Enterprise every day. So be sure to visit modernenterprise.ai to learn more. This is fantastic because I think so many people, to your point, they want the shiny toy, they skip ahead, and I think the way that the headlines are reading and the way that AI is kind of operating today for enterprises, it's just too easy to go there and to forget about the foundation, which is going to have long-term implications. So once the foundation is strong, speed still matters. VDURA's architecture is known for balancing performance and resilience. What design philosophies enable you to achieve both, especially at the AI and HPC scale?
Sure. This is pretty fundamental. So I joined VDURA, about 2.5 years ago. The company was formerly known as Panasys. As Panasys, it was one of the pioneers of parallel file systems. But before I came here, I'd worked on various other parallel file systems over my 30-year career in storage. And what I can tell you is historically, high performance storage infrastructure, if you will, was very much focused on speed at almost all costs. Think of it as the Formula One race car. Its objective is to go around the track as fast as possible, but unfortunately, it would historically require a lot of pit stops. It would require an expert crew to debug the issues and get the car back in the track again. In the new world, particularly of AI infrastructure, downtime. If the file system is down, your compute cluster is down. If you're spending millions, tens of billions, hundreds of millions, and in some cases billions of dollars on that infrastructure, literally every minute, never mind hours, days, and in some cases even weeks, where customers experience extended downtime of legacy parallel file systems, that's just not acceptable going forward. So where we looked at as we founded Vidura, we wanted to focus not just on velocity. Look, performance in our game kills, so performance is absolutely critical, but not at the expense of a durability. And that's really where we come to the operational reliability of the system. Not only, again, to use the car analogy, can the car go fast? It needs to be a production sports car. It needs to be able to go around the track on many different roads, many twisted twists, very different different environments, not require frequent service and not necessarily require its own on staff pit crew to keep it up and running. So it was really important for us with Vidura to really harness what was great around our core technology, which was, again, a really pioneering parallel file system, but add incremental capabilities to that really extend our ability to be operationally resilient. And again, the more I talk with customers, particularly those running AI factories, operational resiliency that translates into lower cost per GPU per hour, lower cost per token is foremost in their minds. And that's where we kind of come in with a pretty different architecture. We have something that the way we do erasure coding is pretty unique in the industry. We do something called file level erasure coding. It's our version, if you will, of network erasure coding. That means that we take data and instead of doing local RAID within the system, we actually do network erasure coding. That means if a node goes down and we've built out a cluster of nodes, if a single node goes down, we really don't care. It's got minimal impact on the system. Minimal impact in terms of performance, minimal impact, actually zero impact in terms of durability. Even if you have a cluster and to say a cluster of storage cluster of 10 nodes, which is not many, we can handle up to 2 nodes going down and your data is still protected and your system's still available. That's very different from traditional parallel file system architectures that don't have this concept of file level erasure coding, where the failure of a single node could bring performance of the entire storage cluster undergo your compute cluster down in half. The failure of a second node means your storage system could be entirely offline and require a lot of manual steps or go a lot of downtime to get it back on. So our architecture is orthogonal to that. As I said, one of the ways you need to judge your data storage infrastructure, its ability to handle failures online in an automated fashion. So that's where we really blend the linear scalability of a true parallel file system, but with the durability most often associated with like cloud scale object stores. Our technology, our architecture brings the best of a parallel file system in terms of true linear scalability and performance, but with the durability and availability of an object store, we bring that all together to one infrastructure.
Many leaders think of failover only at the networking layer, but storage resilience is just as critical. That distinction alone will change how people evaluate their infrastructure.
I
So,
used to work with a lot of networking people, and I would slag them quite a bit because, like in networks and switches, bits get dropped all the time. Yeah,
mhm.
in storage, you can afford to lose a bit. You can afford to lose a bit. You can have a bit corrupted. The standard of data availability and data protection in terms of overall, again, putting underneath that umbrella term of operational reliability. Again, it's just a different level, a different standard. That's why customers need to specify availability, durability critically, because otherwise what you will get is something that goes really fast, that's cheap, but not reliable. You can actually get both. You can get something that's really fast, has great economics and great operational reliability.
That's awesome. All right. So for everyone listening, you need to make sure that you're checking that box, not just at the networking level, but you also need to make sure that you are critically checking that box when it comes to storage. That
For sure.
is an incredible insight. Thank you. And okay, so we're durable and we're going as fast as is possible, or as we should be. And then we've got the foundation laid. Okay, so let's talk sustainability and cost. Two pressures that are increasingly inseparable. How does VDURA address the need to reduce energy use and optimize data movement without sacrificing performance?
Sure, it's a great question, and given that so many of our customers are obviously power constrained in terms of their data center infrastructure, never mind just the cost, the broader economic impact of again a grid that is straining under the pressure of AI infrastructure growth. Yeah, very topical question and conversation with our customers. So what we really think about here is operational, not just reliability, as I talked about, but flexibility. So when you think about carbon and the cost equation, there can be a trade-off. There can be a trade-off between the unit cost, and then there can also be a trade-off between the environmental impact. So let me explain what I mean by that. So when you think about building out your infrastructure from a performance perspective, flat from and storage infrastructure, Flash is the most price performant, I would say, efficient storage media for us to use. Now, you need to think about the network, you need to think about the compute infrastructure, you need to think about the storage stack and its ability to translate the raw capability of that very expensive, and Flash is very expensive relative to other options. You need to think about how efficient can my infrastructure, again, the infrastructure being a combination of the hardware and the software, get that performance that the raw media is capable of and actually deliver it, through my compute cluster and ultimately to the applications. This is an area that I am very passionate about. Going back to my original history in HPC, when I did I would say my first HPC storage business, one of the things that we really focused on there was infrastructure efficiency. Without going through all the history, before we came along, storage infrastructure, in terms of if we took all the capabilities of the raw media and translated in and compared to what its theoretical maximum performance should be versus what was being delivered, was like 15% efficient. So 85% inefficiency.
Wow.
But we're really fighting, which is just you blows your mind and actually
Yeah.
blows my mind today, where I've got many customers who specify, hey, I just want to go all flash. And they have no real reason. Um, to specify all flash. As a customer, what you should be specifying is and challenging the vendors is like, hey, I need this amount of performance, I need this amount of capacity, and I want to do it for the least amount of power, and I want to do it for the least amount of capex, because obviously the
Mhm.
biggest determinant of your TCO, the biggest element of your TCO is that upfront capital expenditure. So
Right.
what we really focus on is to make sure, hey, not only can the flash that we're using, I want to make Mr. Customer that if theoretically you can go 100 miles an hour, we want to get as close to that theoretical performance as possible and not leave any waste, any inefficiency on the table. And that's where we look at obviously the efficiency of our software stack and as we're software defined, but making sure we fully utilize the underlying hardware infrastructure. So the first thing I would say to customers is, again, are you thinking and you asking questions of your storage vendors? How efficient is this infrastructure? Efficient in terms of performance per gigabytes per second relative to the underlying media? Because again, if you're asking me to buy millions of dollars of flash and you're telling me to buy millions of dollars of flash because it's more performant, well, if you can't translate that performance through your hardware infrastructure, through your software stack to meet the needs and feed it into my GPUs, I'm just wasting money. I'm not just
Mhm.
wasting capital infrastructure, I'm wasting operational infrastructure. The second element of cost when you think about storage, which is what everyone historically thinks is your price per terabyte, your cost per terabyte. And that is where there's a huge discrepancy between flash and alternative media, particularly HDDs. When you look at what the hyperscalers do, which run the largest AI factories in the world, they all uniformly have a very common infrastructure where they have 10% of flash and roughly 90% of HDD. You want to get the performance that you need from that flash layer to the point that you asked earlier. You want to be in make sure you have the right data in the right place at the right time. So if I need to read it and I need to write it, I'd like it to be in Flash. But if I'm not doing that, which of course the majority of the data that you're storing, you're not accessing all the time, you want
Mhm.
to be able to move that again transparently, efficiently in an automated fashion to a lower cost, both capital acquisition cost, lower carbon footprint, lower power footprint, HDD infrastructure. Now, we are media agnostic. This is very different than a lot of our competitors.
Mhm.
Um,
Mhm.
we can use Flash, we can use HDD. So we will sit down with the customer and be like, right, hey, talk to me about how you're thinking about the carbon equation. What I'll say to the customer is, what elements of the carbon equation are you thinking about? Do you think about just operational cost, or are you also thinking about the embedded carbon footprint that you have in your data center? As an example here, there's been numerous studies done where they looked at the relative carbon footprint of Flash to HDDs, and there's literally an order of magnitude difference between the embedded carbon that would be in a flash versus HDDs, which actually dwarfs the operational costs related to operational cost and the carbon footprint relative to ongoing power. So these things
Mhm.
tend to be a very more involved conversation. Unfortunately, you know, some vendors who are not media agnostic, right, are very just focused on flash and come up with very, frankly, convoluted studies to try and obfuscate the fact of that, hey, it kind of comes down to the raw media. And again, the facts are what the facts are that the embedded carbon footprint of a HDD is a lot less than flash. So what we say to customers again is, look, we're media agnostic. What's the performance that you're looking for? What's the capacity you're looking for? The availability, durability, operational reliability. Let's talk about management. And then we'll put together configuration options for the customer. Hey, we can go all flash. It's going to cost you X amount of dollars. We can put
Mhm.
together a hybrid configuration that has an element of flash to meet your performance needs, in many cases, to more than meet your performance needs in terms of both NVIDIA's and AMD's performance per GPU requirements. But then we can also look at and say, hey, we can have a HDD layer all incorporated into one global namespace, one data plane, one control plane, where we can give you dramatically lower acquisition costs.
Hmm. I think that's a nuance many enterprises miss. They default to all flash without recognizing that media choice is a strategic, economic, and carbon decision. Do a lot of people take into consideration what their raw media is when they're approaching? Is that even something that they're thinking about when they're trying
I
to
think
solve for this?
it depends on the customer, frankly. Like more educated, more experienced customers are very aware of that. When you're building out, it's no different, frankly, than the GPU compute infrastructure, where the CPU is the majority of the bill of materials, the physical
Hmm.
bill of materials. It's the same thing with your, storage infrastructure when you think of the hardware. The
Hmm.
media is by far, and should be if the system's well designed, the media by far, i.e. greater than, should be more than 60% of your physical bill of materials. So you want to make sure you're focusing on the media. And what I always say to customers is like, well, look at what the hyperscalers do. The multi-trillion-dollar companies, they probably know a thing or two, and there's a reason why they have these. It's not flash versus HDD. That is a tired, lazy argument. It's like fake
Mm.
news. It's I'm going to have a fleet, and in that fleet, what makeup do I want? And by the way, the makeup might be one thing today, and it might be a different thing tomorrow. As an
Hmm.
example, today I might be running AI. AI might be a subset of my applications. In that case, my performance requirement is X. But tomorrow I might have a lot more AI applications. And by the way, we're bigger GPUs and faster networking. So I want my storage infrastructure performance to be able to scale. And at that point, maybe I want to add more flash nodes and change the ratio of flash to HDD in my infrastructure over time. Because again, the other piece of it, these things that since the media is 60% or more of the bill of materials, well, those media are commodities. Right. So again, no
Hmm.
different than, soybeans or gold. Sometimes commodities are cheap and sometimes they're expensive. So sometimes flash is cheap relative to HDDs. In that
Hmm.
case, use more flash. Other times, like right now, flash is at an all-time high. It's incredibly expensive. So in that case, you might want to buy a little bit of flash and buy more HDDs, and maybe in a year's time or 2 years' time or 6 months' time, when the price of flash drops, then buy more flash and add more in, right? And I think too often customers just get locked into what do I need, what's right in front of me right now, and go and buy everything. You don't
Hmm.
necessarily need to
Hmm.
do that with storage, again, because it's a commodity and it changes over time. You can, expand, upgrade your storage infrastructure over time.
Yeah, that's incredible. That's not what I'm hearing in the market is people are, to your point, just going all in. They're not taking that incremental approach when they have that option. Okay. So looking ahead, how do you see near data compute and model native design reshaping storage and infrastructure over the next 3 to 5 years?
Yeah, I think it's super exciting. As I mentioned earlier, I think we really are in the midst of this huge shift from general purpose computing and ergo general purpose storage to accelerated computing, and really if we can term accelerated storage. So that'll be the first kind of foundational shift, and that is, I think, the entire storage market is really shifting from that, following where compute's going, following where the applications are going, and going from that older world of SANs and NAS and block storage devices into this world of distributed infrastructure. And in that case, specifically parallel file systems. So that's certainly for us as a pioneer parallel file systems. That's super exciting for us. And then where do we see it even further going? So again, there's as the compute infrastructure and as the networking continues to scale, performance is going to need to scale. We're going to move from PCI Express Gen 5, we're going to go to PCI Express Gen 6. That's again going to mean that the backend storage devices are going to get faster and faster, which puts more pressure on the storage infrastructure to be able to scale and be more performance and more efficient. When you think about that efficiency, the storage is done in multiple different places. So you made a great point there is, do we move the storage closer to compute? And in doing so, how do we avoid the trappings? Again, going back to being storage for a long time, it's like fashion. We had the world of direct attached storage, and then things moved to network attached storage with NAS, and then things to storage area networks with SAN. And part of that was, hey, you don't want to have storage just dedicated in a silo located in an individual node.
Mhm.
That's why we moved to shared external storage, if you will. I think there's a little bit of a blend of both worlds as we go forward. That you're still going to obviously have shared external storage, so I can have separate infrastructure that I can scale my storage independently and have all those that SLA that we talked about in terms of resiliency, availability.
Mhm.
But it's clear that particularly when you're doing GPUs and you think about KV caches and local storage within the node, there needs to now be a way to utilize that capability of that high performance node local storage, but again, not having it in a silo. How do you put that together into all one singular namespace, one data plane and control plane, where it can have an SLA that is literally aware of where the data's locality, right? As we think about tiering, as we think about performance, as we think about availability, all these different elements that are a part of the contract that the storage infrastructure needs to provide to the compute and to the application. So I see a lot going on here. I think we're going to see a lot of innovation over the next even year, 2 years, that because there needs to be, because as we see with NVIDIA in particular coming out with a new architecture, a new GPU every year, and performance just goes up and up, the storage infrastructure needs to be able to respond to that.
It's incredible. Yes, as that space becomes, as performance goes up, it seems like it becomes incredibly more complex in terms of the needs that data storage has to meet. And even as complexity increases, the experience needs to feel easy. It needs to feel simple. Otherwise, operational overhead erodes ROI.
Yeah, well, yeah. So this is like where again, back to the original point on silos. Customers really need to carefully think, and I always say to them is like, when you're putting in an RFP for storage, it's so tempting to like, okay, what do I need today? You've got to ask yourself and the team, okay, but what are we going to do when this infrastructure is 10 times bigger than it is today? Because hand on heart, none of us knows. If we all knew we just buy shares in the stock market, we know exactly what's going up. We wouldn't be here working for a living. But you've got to think about the future is unknowable, and how do I make sure that I have an infrastructure that's able to adapt to my unknown future needs.
Mm-hmm. Yeah, it reminds me of one of my favorite ads from Clark's. Simple, it's complicated, right?
Yeah, yeah, yeah. And like
Yeah.
that's, if you think about for our customers, really our goal, as I said, is to create like this architecture or go this, data storage infrastructure that's literally infinitely scalable in terms of performance, in terms of capacity, do it all online, non-disruptively. And yeah, I'd like that to be able to be done with just a few clicks of a button and have it all visible through a single pane of glass. And if anything fails, I want to not have to worry about. I want the system to be smart enough to be, intelligent and automated in the way I handle those failures. I don't want to have to worry about moving data from Flash to HDD and back. I want the system to have the intelligence to be able to do that. And that's really where we want to be. We want to have the right performance for the customers. We want to have the right economics. And again, I always say I will talk more about economics to customers than I think most of my competitors. I just think having been in factories, run factories, efficiency is really important. But then the last piece of the leg of the stool is certainly simplicity. And that all comes from having the right operational reliability built in. If the storage infrastructure is operationally reliable, it's very easy to manage. If it's not operationally reliable, that's where you lose your weekends. You're getting those phone calls in the middle of the night going, storage infrastructure is down. We don't want our customers to experience that.
No, no. And I'm sure they don't. So,
For sure.
um, if you were advising a CEO or a CIO today, what three questions should they be asking about their data layer to ensure AI readiness, trust, and competitive advantage?
Great question. I think if we can draw on the factory analogy, because I do think it's a good one and it's very appropriate, because I think again, it's a mindset shift that I'm seeing with many customers where again, it's almost like you can talk about going from a cost center to a profit center. I think
Mm,
again, you got to think about, hey, I'm running a factory. If you're running a factory and you just step back, what are the things you care about a factory? Well, like what's the goal of a factory? The goal is of a factory is to take a certain amount of inputs and create a more valuable output. And whether that output again is, you're monetizing it, is whether you're building widgets or you're going to charge per GPU per hour, or you're going to charge per token, whatever the key metric is for your factory, efficiency is everything, right? Again, at the end of the day, for a factory, it's a big capital investment. And your job as the person running that factory is to make sure for the dollars capital that I'm investing, how do I make sure that I'm getting the most outputs out at the lowest unit cost? And you need to think about everything from the compute, the networking, and to the whole purpose of today's conversation, even though it might be not the majority of the budget, the critical underpinning of that factory floor is your data storage infrastructure. So again, how efficient is that storage? Am I able to meet the GPU requirements? Again, not only for today, but for the next generation, because you want that storage infrastructure to last you a minimum of 5 years so you can have a proper depreciation cycle. If you can run 6 or 7 up to 10 years, that's an important. Hyperscalers run 5, 6, 7 years. So you want to be able to have an infrastructure that you can credibly depreciate over a minimum of 5 year cycle, meet the GPU requirements, and then the piece, how efficient is that infrastructure? Back to what we talked about. If I'm buying a bunch of flash, buying a bunch of HDDs, in terms of what the raw media is capable of, how much of that raw performance am I able to translate into my GPU cluster? How much of that raw capacity is available to my users? So these are efficiency metrics. And then again, it's a factory. What's your yield going to be? If your yield isn't over 90% and you're running a factory, you're losing your job. So you're going to make sure, what's my yield? Well, my yield is what's my availability. If my storage goes down, my compute is down. Not good. If I'm doing a checkpoint, which is the most demanding portion of an LLM model from a performance perspective, and certainly for storage, when you're doing that training and you're taking a checkpoint, a snapshot of all the data that's in the compute node's memory, while you're doing that, the compute infrastructure is idle, right? You need to be able to write that checkpoint frequently, and you need to be able to get it to persistent from volatile storage. You need to get it to persistent storage as fast as possible and reliable. So again, performance, got to make sure the overall system is available. If my storage goes down, no compute, no good. I got to make sure that the data is there. I've just spent 30 days training a model. Oh, sorry, we lost a couple of terabytes of data is not an acceptable answer. If you don't specify your durability, you're leaving yourself open to that risk. So these are the things that I would think about: efficiency and then adaptability. Hey, this is the number of compute nodes that we're deploying today. This is what my model looks like. Okay, but what if tomorrow the model that I'm doing becomes more, which likely will, more visualization intensive, completely changes my storage IO performance requirements. So am I building the storage infrastructure for the minimum requirement today, which is roughly about 0.5 gigabytes a second on reads, about 0.25 gigabytes a second on writes. But that could be up to 10 times that if I do a lot more visualization. So again, am I building an infrastructure for today, or am I building an infrastructure that's going to give me the headroom tomorrow? And again, you can also balance and say, hey, I need adaptability because I want to build it for this today, but I don't want to spend all the capital up front. I want to build the capital that I need, but I want the operational flexibility that if my workloads change, I don't have to buy all new infrastructure. I can just incrementally add to that. That's part of the adaptability and efficiency. And then the next thing is just complexity. So again, I want to think about my AI pipeline as one holistic pipeline. If I have storage infrastructure A, B, and C, and D, and E, depending on each different stage of the pipeline, and they're all different stacks that don't work together from different vendors that don't work together, that's a recipe for disaster. That's just complexity. So I want to look at it and go, okay, can I get a storage infrastructure from one or two vendors, but that actually work together and can meet multiple different stages of the AI pipeline? How do I have that, easy button as you talked about? It's difficult, but you definitely, if you don't plan for that up front and drive that as a key architectural principle, manage, minimize complexity, maximize adaptability, maximize efficiency, both from performance and capacity perspective. If you don't challenge your team with those meeting those key requirements, you're just going to create a problem for yourself of architectural debt, and that debt will have to be paid down the road. Avoid it. Get it right up front.
That is fantastic. Ken, this has been absolutely invaluable. If you're listening, you now have the thinking frameworks and the questions you should be asking as you evaluate your AI infrastructure. Thank you, Ken Claffey, CEO of VDURA, for joining us and helping support our mission here at Modern Enterprise Unpacked to to give leaders clarity on when, where, and how to hedge their bets in this era of AI. Thank you everyone for listening. Please remember to subscribe, share, follow, and join me for the next episode of the Modern Enterprise Unpacked.